Good morning, students. We have completed with the preparation and reactions of haloalkanes. Today we will start with aryl halides or haloarenes. So what is aryl halides or haloarenes? Now this is an aromatic ring. What is this? This is benzene. When a halogen is directly connected to the benzene ring, the compound is known as aryl halide or haloarenes. For example, see this compound. Here we have benzene and Cl is attached directly to the benzene ring. So this is chlorobenzene. If it is Br, then it will be bromobenzene. Similarly, we have iodobenzene, fluorobenzene. Now, what about this compound? Is this an example of haloarenes or aryl halides? No, this is not haloarenes or aryl halides. See, in haloarenes or aryl halides, the halogen is directly connected to the benzene ring. See this carbon, this is sp2 hybridized. But here the halogen is connected to sp3 carbon. That means this halogen or Cl is not connected directly to the benzene ring. So this is not an example of aryl halides or haloarenes. Now we will start with the preparation of haloarenes or aryl halides. Our first method of preparation of aryl halides is from benzene or aromatic hydrocarbon. So from aromatic hydrocarbon. So our aromatic hydrocarbon is benzene. So let us prepare chlorobenzene from benzene. Benzene plus chlorine in the presence of Lewis acid. The reaction takes place in dark. What we will get? We will get chlorobenzene plus HCl. So we prepare chlorobenzene from benzene by halogenation of benzene. Halogenation in our case it is chlorination. Now, this conversion of benzene to chlorobenzene in the presence of chlorine and FeCl3 is known as nuclear halogenation. Now, this halogenation or nuclear halogenation of benzene is an example of electrophilic substitution reaction. Electrophilic substitution reaction. Now when we are converting benzene to chlorobenzene, we are using Lewis acid. Now, what is the function of this Lewis acid? Now, this Lewis acid helps in the generation of the electrophile required for this electrophilic substitution. And the electrophile that is generated in this halogenation reaction is chloronium ion. So, this Cl plus is the electrophile. Who is helping in the generation of the electrophile? Lewis acid. Here the Lewis acid is FeCl3. It can be AlCl3 also. Now in this particular reaction we will see that how this Lewis acid helps in the generation of electrophile. For this we have to go through the mechanism of electrophilic substitution of benzene to yield chlorobenzene. So now we will see the mechanism of this particular reaction. Chlorobenzene plus HCl. So this is an example of electrophilic substitution reaction. So in electrophilic substitution reaction, the first step involves the generation of electrophile. So write in your copy, mechanism of chlorination of benzene or mechanism of halogenation of benzene. Within bracket write electrophilic substitution reaction. The first step is generation of electrophile. We have Cl2 with us and this Lewis acid FeCl3. So what is Lewis acid? Lewis acid is acceptor of electron. That means Lewis acid itself is electron deficient. Now this FeCl3 will draw electron from here. As a result, this bond will be broken and we will get Cl plus, which is our electrophile, plus FeCl4 minus. So write the first step, the generation of electrophile. So who is helping the generation of electrophile? FeCl3. Now let us see the second step. The second step will be attack of this electrophile. Attack of E plus. Let us see who will attack this E plus. In our case, E plus is Cl plus. Now these are the pi bonds of benzene ring, and here we have Cl plus. So take any pi bond of your choice. So I am taking this pi bond. This will attack this electrophile. So what will happen? Here you have two electrons. So one electron will neutralize the Cl and another electron will help in the formation of bond. Let us see this. This bond intact. This bond is here. So what will happen? Here if you attach Cl to this carbon. See 1, 2 electrons. Here one electron already it has neutralized. Another electron is a bond over here. If you are attaching the Cl to this carbon, this adjacent carbon will become plus. Suppose if you are attaching Cl to this carbon, then this carbon will become plus. Now this particular structure will have a number of resonating structures. So let us see the resonance of this. So now this will shift here. You will get here it's a plus previously. The second step is the attack of Cl plus or the attack of the electrophile. Let us see who will attack the Cl plus. Here you have the benzene ring. Now these pi electrons are comparatively loose. So what they will do? It will attack the Cl plus. This bond intact. So if we were attaching this Cl to this carbon, then the adjacent carbon will become plus. Now it will have a number of resonating structures. So let us see the resonating structure. This will come here. So this is Cl, this bond intact. This is becoming plus and the pi bond will shift here. In the next step, what will happen? This one Cl. Now this is becoming plus. So you see that the plus is coming at the ortho position and para position. Now we can represent all the structures as this sigma complex. That means if you are putting the Cl here, see the sigma complex will be like this. That means plus charge at the ortho and the para position and the pi bond is circulating. So this is the sigma complex. That means the structure is quite stable. So now in the next step, what will happen? First you all write this. Our third step involves the removal of electrophile. See, suppose this one is benzene. When you are treating benzene with chlorine in the presence of halogen carrier, that is a Lewis acid FeCl3, we are getting chlorobenzene plus HCl. Now this H of benzene is being substituted by Cl. So it is a substitution reaction. Now what it is? Electrophilic substitution. Because H plus, that is electrophile, is substituted by Cl plus. So the third step involves the removal of electrophile. So in our case, it will be removal of H plus. So in the previous step, we have seen the formation of this sigma complex. We have discussed the structures, or rather the resonating structures. Now next step, what will happen? Here we have one H. Now this H will be removed as H plus. So minus H plus. Now who will snatch this H plus? Obviously a base. Now where is the base here? FeCl4 minus, that we have obtained in the first step when we have discussed the generation of the electrophile. This FeCl4 minus will abstract this H plus and the product will be chlorobenzene plus HCl plus FeCl3. So we can also say that FeCl3 is acting as a catalyst because it is regenerated in the reaction. So this is about the electrophilic substitution reaction of benzene leading to the formation of chlorobenzene. So we have learned that halogenation of benzene is an example of electrophilic substitution reaction. Similarly, when we treat benzene with bromine in the presence of FeBr3 as the Lewis acid, we will get bromobenzene. Now what about iodobenzene? Suppose if I treat benzene with iodine, we expect this, but this Hi is a strong reducing agent. So what this Hi will do? This Hi will reduce the iodobenzene formed to benzene again. That means this reaction will be reversible in nature. So to check the reversibility of this reaction, we have to use a very good oxidizing agent. You can also use nitric acid. So if we iodinate benzene in the presence of HiO3, then we will get iodobenzene. But the preparation of fluorobenzene by this method, that is by direct halogenation, is not possible because benzene reacts with fluorine violently. So we have to devise some indirect methods of preparation of fluorobenzene. We will learn it afterwards. Our next method of preparation of aryl halides is from aniline. Now this is the structure of aniline. First, we will convert aniline to benzene diazonium salt. This is known as benzene diazonium chloride. So how to convert this? We will treat aniline with sodium nitrite plus dilute HCl in 0 degree centigrade to 5 degree centigrade. Now this will convert aniline to benzene diazonium chloride, and this reaction is known as diazotization. So what is diazotization? When a primary aromatic amine, let it be aniline, treated with NaNO2 plus dilute HCl at 0 degree centigrade to 5 degree centigrade, we will get benzene diazonium chloride. This reaction is known as diazotization reaction. So, for the preparation of aryl halides from aniline, first we will convert aniline to benzene diazonium chloride, and from benzene diazonium chloride we will see how we can prepare chlorobenzene, bromobenzene, iodobenzene and fluorobenzene. So now we have with us benzene diazonium chloride. Now if I treat this benzene diazonium chloride with cuprous chloride in the presence of HCl, we will get chlorobenzene. Similarly, if I treat this benzene diazonium chloride with cuprous bromide in the presence of the halogen acid HBr, we will get bromobenzene. Now this method of preparation of chlorobenzene and bromobenzene from benzene diazonium chloride is known as Sandmeyer reaction. So Sandmeyer reaction involves the formation of chlorobenzene and bromobenzene from benzene diazonium chloride. Now, we can convert this benzene diazonium chloride to chlorobenzene and bromobenzene by another method. Now, instead of treating Cu2Cl2 or CuCl with HCl, now we will treat freshly prepared mixture of copper with HCl, and here copper with HBr. So, benzene diazonium chloride, copper, HCl, chlorobenzene. Then benzene diazonium chloride treated with copper oblique HBr, giving us bromobenzene. Now, this modified Sandmeyer reaction is known as Gattermann reaction. Now we will see how to prepare iodobenzene and fluorobenzene from benzene diazonium chloride. So if you were asked, convert aniline to iodobenzene. So what we will do? First we will treat aniline with NaNa2 oblique dilute HCl 0 degree centigrade to 5 degree centigrade. So we will get here benzene diazonium chloride, N2 plus Cl minus, this one is benzene diazonium chloride. Now I will heat this benzene diazonium chloride with aqueous Ki. I will get here iodobenzene. So aniline, benzene diazonium chloride, then we will heat this benzene diazonium chloride with potassium iodide and we will get iodobenzene. Now how to convert aniline to fluorobenzene? Similarly, we will heat aniline or we will convert aniline to benzene diazonium chloride first. Then if you heat this benzene diazonium chloride with HbF4, then we will get fluorobenzene. So this is the route. Aniline, benzene diazonium chloride, heated with HbF4, we will get fluorobenzene. And the same benzene diazonium chloride, when you will heat it with potassium iodide, you will get iodobenzene. And what about chlorobenzene and bromobenzene? This benzene diazonium chloride, when you will treat it with Cu2Cl2HCl or CuCl-HCl, you will get chlorobenzene. And the benzene diazonium chloride, when treated with CuBr oblique HBr or Cu2Br2 oblique HBr, will give you bromobenzene. Now suppose if you were asked that convert this compound. Do you know what is the name of this compound? This is silver benzoate. COOH, that is benzoic acid. H is being replaced by silver, so this is silver benzoate. If I ask you this conversion, silver benzoate to bromobenzene, how to carry out this conversion? See, when you will reflux this silver benzoate with bromine, carbon tetrachloride, we will get bromobenzene. What is the name of this reaction? Hunsdiecker reaction. We have studied this reaction in haloalkanes. Hunsdiecker reaction. So this is about the preparation of aryl halides. Now let us carry out one conversion. If you were asked that convert iodoform to chlorobenzene. See, this is aromatic compound. This is aliphatic compound. Now here we have to convert iodoform to such a compound which will act as a bridge between aliphatic compound and aromatic compound. One such compound which can act as a bridge is acetylene. Now we will convert iodoform to chlorobenzene. So first we will convert iodoform to acetylene. How to bring about this conversion? We will heat iodoform with silver powder. We have learned this reaction in class 11 in the preparation of acetylene. So iodoform to acetylene. Now acetylene to benzene polymerization reaction. Copper 400 degrees centigrade or copper 600 degrees centigrade. This is polymerization. Now this benzene, when I will treat with chlorine in the presence of Lewis acid, it can be FeCl3, AlCl3, whatever. So dark, temperature is ordinary temperature. We will get chlorobenzene. So iodoform to acetylene, acetylene to benzene, and benzene to chlorobenzene. In our next class, we will discuss the chemical reactions of aryl halides. Thank you very much. Have a nice day.